In the last video, I exported the solved camera and scene to an FBX file. In this video, I will import this file into Houdini and build a simple scene to add a 3D object to our footage. I will create some materials and lights for a Redshift render. This can also be done in Mantra if you don't have Redshift, but that will not be covered in this tutorial. Also in this video, I finally figure out that the solved camera is upside down. I may try to figure out what causes this and how to fix it in a future video. This video is a bit longer than the others, mostly because I'm still learning most of these things myself, and it takes me a bit longer to find tools and figure things out within Houdini. I hope the resulting video is still useful. All right, from within Houdini, and I apologize if this seems really small, we can come in here and we're ready to start playing with this. So the first thing I'm going to do after saving is we're going to do the FBX import of our little object, which we called conveniently Jimmy Track A FBX. We generally want to pull most everything in. Before I start, I want to fix one thing over here though. We need to change the starting frame to 0. Houdini likes to start at 1, and you will be one frame off if you don't change that. So we're going to import this file. Every frame. This should be okay. We did export the scene frame range, so it should put it in the right place. Otherwise should be okay with the conversion to a Y up. We'll import it not as a new scene, but as one scene here. So first thing we notice is we don't have a very good view. We need to change to the scene camera. And one thing I've found is that for some reason Houdini always gets the camera wrong. So we're going to come in here, and to start with I'm going to turn off the cube and the ground plane so that we can figure out what's going on with the camera. This plane is the plane that was generated to store the camera image. Houdini doesn't really work this way, but it does help us get the camera adjusted correctly. So if we come into the camera, in the view, the aperture seems to be 11.88. We need to shrink this just about a little bit more so that it just fills the edge of the camera that we're viewing. I don't know why this is necessary, given that it exported all of the camera details. Also want to make sure we set our resolution correctly so that when we do render something, it will be at the correct resolution. Now I can turn this little camera plane off, bring back our ground plane, which is just a large plane, so that's not particularly useful, and our cube. We'll need the ground plane in a minute though. Now if I pan through this, it should roughly match our footage, but there's an easier way to find out. If we go into the camera itself, and you set this background image to our source footage. This is why I wanted these as separate ping files. Now, Houdini will show us each frame on top of the background image at this camera. So if we just play, our little cube should track quite nicely in the image. Now's the part of our work where things get kind of interesting. Instead of this very dull cube, I'd like to add something to this scene, something interesting. So, in light of, standard interesting things, if I can remember the key shortcuts between these, it's Shift Space to bring up the object insertion, the node insertion menu in Resolve and Fusion, and it's Tab in Houdini. So I'm going to go down here for Test Geometry, and I'm just going to pick the rubber toy. So I honestly don't know why it's upside down. It's positioned quite weirdly, in fact. So if we leave our camera, this is really strange. I don't know why this is upside down. Let's try adding something else. Is the pig head upside down too? The pig head is upside down too. This must have something to do with our scene itself. So this is easy to fix though. Let's just rotate this thing 180 degrees. Something like that, and then maybe do a uniform scale to a smaller size. So first thing I want to do though, this toy does not sit nicely with the ground plane. It kind of sticks through it. So I just want to make sure that we actually are sitting very close to on the ground. We can be slightly below the ground, but we don't want to be too much below it. So if we return to our scene, this is not positioned meaningfully at all. Wow, those are hard to see. So I'm just going to put this little toy maybe here. I want it kind of away from the shadows because that would cast a shadow on it. And hopefully the light is up high enough that it doesn't cast a shadow on any of the objects in the room. And then I'm going to rotate it so that it's kind of like that. So that should give us this toy object in the room. There's no animation, but we're good with that. So lastly, we need some lighting, which, given that the camera tracking was all done magically for us, this is probably the most difficult part about this. I'm going to start with just a dome light to give kind of an ambient feel, along with an area light somewhat directly overhead to try to match the shadows that are on objects in this room. I'm going to do all of these with Redshift lights. We'll put this dome light in here. So this should give us it's getting lighting behind it, so I don't. I didn't create a material for this, so it seems to be trying to get that from the Houdini shader. So I don't actually know why this is doing any of this. Getting into new territory here. Oh, that's because it's a mantra view. That's why the mantra shader worked and this light didn't. All right. Let's go in here. Let's just delete the mantra shader. Create a pair of shaders for Redshift. Link this here. Pick the camera we have. This should give us our scene without anything. All right. Give me just a minute to fix my license error. All right, I'm back now with a working Redshift license. As we can see when we go into render view, we get this, well, dreadfully awful view. So we need to come up with some materials. So I'm going to do this the traditional way. Create a Redshift material builder. We'll call this one rubber. Create one more Redshift material builder. We'll call this the shadow catcher. So within the rubber material, we just create an RS material, connect its out color to surface. In here, we can select plastic, give it a kind of a bluish tint, but not quite that dark. So maybe something like that. This should give us at least, oh. So this object has a shop material path associated with it, which overrides the material. So this is easy to fix with an attribute delete. And that gets rid of the really nice looking materials that are associated with it. Ideally, we would actually replace these with several different materials. I can do that as a more of an exercise. Now we get this blue, excessively shiny rubber material. I'm a little concerned about it being so shiny. Just because it is we don't want to be getting reflections of objects in our scene. It's not even enough roughness, is it? That's a little better. It's not beautiful, but it's a start. And the other thing we want to get going is our ground plane. Which we want to use as an RS matte shadow catcher. Just feed this in. There's not much to do to this. Just let it catch shadows, and it should do the right thing. Set our ground plane to this. Now in here, It's kind of hard to see what it's doing, so it's actually easier to return this back to the Phong shader that was imported. Just pick one, it doesn't really matter, since they don't do the right thing anyway. This gives us an idea of what shadows we're getting from this. We have a diffuse slice, which gives us ambient occlusion, but we do need an overhead area light to simulate the lights in the room where this was captured. That's not a pretty color. I don't even remember which one it was before. Well, regardless of being painful and loud, let's just turn it off for now. We need to get an overhead light. So I will bring in Redshift. Let's just do a Redshift light. Place it. This particular light, we want to be on, set it to an area light, and now we just need to position it meaningfully. Should be up in this direction. And probably, just guessing, over here somewhere. The area needs to be pretty large. Because it's kind of simulating the ceiling reflecting a lot of this light as well. The only thing is that that's probably painfully bright. So we can just set our intensity multiplier to maybe 10.5. Let's try 2. And the light can't be in front of the camera. Our whole scene is upside down. It's an interesting consequence of... So just make sure this light is out of the way of the camera. The upside down feature happens sometimes. It doesn't really know which way is up. We could flip all of this, but I'm not going to do that for this tutorial. So other than not having any shadows, this looks okay. There we are, ground plane is on. The shadows don't actually seem that harsh, so I think what I need to do is turn down the dome light to maybe half, turn this up to maybe 4. I think this looks pretty good. Now, normally I would that's probably good. Normally we would, I think the area is a little bit too large. course, the area has to do with the so we're not getting all that diffuse a light here, but this will probably look okay once we've given it the right shader. Now, normally we would want to separate the different planes. Let me get this set right here. We'll set our material back to the shadow catcher, which should give us this object here with some shadows under it. I think this is probably going to look okay. We normally would want to go into Redshift here. Make sure we've got this set. This looks okay. So get an idea if we have enough noise, but for now I think this is fine. One of my to-do tasks is to go in and figure out enough of Redshift to know how to output the multiple layers, because you generally don't want a single RGBA file. You would like your shadows to be in a separate layer. Main thing I want to do here, so we can render to mplay. Should give us an idea of what it looks like. A little bit noisy. It'll be okay for telling if this process worked. So we can render frame range, which should be 0 to 766. And output these half floats. This all should be okay. These should all be linear. So if I say render to disk, oh, now I remember what I needed to do. I want to turn on motion blur. Just basic motion, not mesh deformation. Give us a little bit of motion blur to try to match that the camera would have captured. There's one other setting. Well, we can start this process up. And clearly this is going to take a while, so I will stop the stream for now. Now that we have rendered our scene, in the last video, we will go back into Resolve and composite the rendered object back into our scene.